Forensic chemistry. Forensic chemistry is a multidisciplinary field within forensic science that applies chemical principles and techniques to analyze evidence obtained from crime scene or legal investigations. It encompasses a wide range of analytical methods, including spectroscopy, chromatography, microscopy, and molecular biology techniques like DNA analysis. And now, I'll be discussing the basic forensic chemistry principle. Chemical analysis. Chemical analysis is the systematic investigation and evaluations of composition, structure, and properties of substances, enabling scientists to understand their chemical nature and behavior. Through chemical analysis, scientists can identify and quantify the components of a sample, assess its purity, detect impurities or contaminants, and characterize its physical and chemical properties. Drug analysis. Drug analysis is a specialized branch of forensic chemistry focused on the identification, quantification, and characterization of drugs and controlled substances, utilizing a diverse array of analytical techniques such as chromatography and spectroscopy. This process enables law enforcement agencies and regulatory authorities to identify illicit drugs and designer substances, aiding in criminal investigations, drug enforcement efforts, and public health initiatives. Drug analysis plays a critical role in combating drug trafficking, assessing drug-related trends and patterns, and informing policy decisions aimed at addressing substance abuse and addictions issues. Toxicology. Toxicology is a multidisciplinary field that examines the adverse effects of chemicals, drugs, and other substances on living organisms. It encompasses the study of toxic substances' properties, mechanisms of actions, absorption, distribution, metabolism, and excretion within the body. Toxicologists investigate the toxicological effects of substances on various biological systems, ranging from cells and tissues to whole organisms and ecosystems. Trace evidence analysis. Trace evidence analysis is a branch of forensic science that involves the examinations and comparisons of small, often microscopic, pieces of physical evidence found at the crime scenes or on the victims and suspects. These types of evidence includes materials such as fibers, hair, glass fragments, paint chips, gunshot residue, soils, and other minute particles. Forensic scientists use a variety of analytical techniques, including microscopy, spectroscopy, chromatography, and elemental analysis, to identify, characterize, and compare trace evidence samples. Trace evidence analysis plays a crucial role in forensic investigation by helping to establish connections between suspects, victims, and crime scenes, corroborating witness testimony, and providing compelling evidence for use in court proceedings. Arson investigation. Arson investigation is the meticulous examinations of fire scenes to determine the cause, origin, and circumstances of fires and explosions. These specialized fields of forensic science involves collecting and analyzing physical evidence such as debris, residues, and structural damage to reconstruct the events leading up to the fire. Arson investigators, often working alongside fire investigators and forensic chemists, employ a variety of techniques including microscopy, spectroscopy, and gas chromatography mass spectrometry to identify potential accelerants and determine the ignition source. The findings from arson investigations are critical for supporting criminal prosecutions, insurance claims, and fire prevention efforts, ultimately contributing to public safety and the administrations of justice. Quality assurance. Quality assurance involves a systematic approach to ensuring the accuracy, reliability, and integrity of analytical results and forensic examinations. This encompasses rigorous validation of analytical methods, regular calibrations and maintenance of instruments, implementations of quality control measures, participations in proficiency testing programs, meticulous documentations of all procedures and findings, adherence to standard operating procedures, and ongoing training and competency assessments for forensic chemists. By adhering to these practices, forensic chemistry laboratories can uphold the highest standards of quality and reliability in their analysis, thereby enhancing the credibility and the admissibility of forensic evidence in legal proceedings and contributing to the pursuit of justice. Expert testimony. Expert testimony is a critical component of legal proceedings wherein individuals with specialized knowledge or expertise in a particular field provide opinions or interpretations relevant to the case at hand. In forensic science, expert testimony often comes from forensic scientists, analysts, or other professionals who possess specialized knowledge in areas such as DNA analysis, ballistics, toxicology, or trace evidence analysis. Expert witnesses are called upon to explain complex scientific concepts, present analytical findings, and offer interpretations of forensic evidence to judges and juries. Their testimony serves to educate the court on technical matters, assist in the evaluations of evidence, and help jurors reach informed decisions based on scientific principles and evidence-based reasoning. Instrumentation and technology. Instrumentation and technology are integral components of forensic chemistry, providing scientists with advanced tools to analyze evidence with precision and efficiency. From spectroscopy and chromatography techniques to microscopy and mass spectrometry, a diverse array of instruments is utilized in forensic laboratories to identify substances, separate complex mixtures, and examine trace evidence. Chain of custody. Chain of custody is a crucial aspect of forensic investigations, ensuring the integrity and admissibility of evidence in legal proceedings. It involves documenting the chronological sequence of custody, control, transfer, and analysis of evidence from the time it is collected at the crime scene to its presentations in court. Each person who handles the evidence must record their actions and maintain a clear chain of custody documentation, including details such as date, time, location, and signatures. Chain of custody documentation serves to establish the authenticity, reliability, and preservation of evidence, safeguarding against tampering, contaminations, or loss. Adhering to strict chain of custody protocols is essential for maintaining the credibility of forensic evidence and ensuring its acceptance in court, ultimately contributing to the fair administration of justice.
Scientific evidence application. Applying scientific evidence to decision making, policy development, practice guidance, and complicated issue solving across a range of disciplines and field entails using empirical data, study findings, and accepted scientific principles. It is a methodological procedure that combines knowledge, transmission, data analysis, research, and evaluation to guarantee that plans and actions are supported by solid evidence and results. Importance of scientific evidence application. Scientific evidence is essential in legal situations because it offers factual and trustworthy information to support investigations, court procedures, and decision making. Physical evidence. It is anything that has material importance which can be used to help establish the nature of crime or offense committed or establish the identity of the perpetrator of the crime and may be presented in the court for proper consideration. Biological evidence includes blood, semen, hair, skin cells, and other biological materials that can be used for DNA analysis. and identification. Trace evidence involves small fragments or residues found at a crime scene, such as fibers, glass shards, paint chips, and gunshot residue. Firearms evidence includes guns, bullets, casings, and other firearms related materials that can be used in ballistic analysis to link a weapon to a crime. Impression evidence involves footprints, tire tracks, tool marks, and other impressions left at the crime scene that can help identify individuals or objects. Documents and forgeries includes handwritten notes, printed documents, and other materials that can be may analyzed for authenticity and handwriting analysis. Digital evidence involves electronic devices such as computers, smartphones, and storage media, which can contain valuable information for investigations. Arson evidence includes materials collected from fire scenes such as accelerants, burn patterns, and debris, which can help determine the cause of a fire. Drugs and toxicology evidence involves controlled substance, prescription drugs, and toxic substances found at a crime scene or in a person's body. Tool and weapons evidence includes tools, weapons, or parts of weapons found at a crime scene. Vehicle and vehicle parts includes cars, motorcycles, bicycles, or other vehicles, as well as vehicle parts that can be linked to the crime or used in reconstructions.
Criminal investigation is a systematic process of gathering, analyzing, and interpreting evidence to determine the truth behind a crime and identify the perpetrators. It involves various techniques such as interviewing witnesses, collecting physical evidence, analyzing forensic data, and reconstructing events to build a case for prosecution. The goal is to uncover the facts surrounding a crime and bring the responsible parties to justice. The retrieval procedure for criminal investigations typically involves the following steps. Identification of evidence. Determine the evidence is relevant to the investigation based on the nature of the crime and available information. Securing the scene. Ensure the crime scene is secured to prevent contamination of tampering of evidence. This involves restricting access and preserving the integrity of the area. Documentation. Document the scene thoroughly through photographs, sketches, and notes to capture the layout and condition of the scene. Collection of evidence. Collect physical evidence such as DNA, fingerprints, weapons, clothing, or any other items that may be relevant to investigation. Use appropriate techniques and tools to avoid contamination. Chain of custody. Establish and maintain a chain of custody for all collected evidence to ensure the integrity and admissibility in the court. Packaging and labeling. Properly package and label all collected evidence to prevent contamination, preserve its integrity, and facilitate tracking. Transportation. Safely transport the evidence to the forensic laboratory or other relevant facilities for analysis. Documentation of results. Document the results of the analysis, including any findings or conclusions reached by the forensic expert. Presentation in court. Present the evidence and analysis findings in court during legal proceedings, ensuring the proper procedures were followed to maintain its admissibility. Throughout the retrieval procedure, it's essential to follow established protocols and guidelines to ensure the integrity and admissibility of the evidence in the investigation and legal proceedings.